Okay, you'll notice that lookup for the circuit is the same as the previous lesson where I taught you how to make a distance sensor for the ultrasonic sensor. Yeah? So just a revision. So the buzzer goes to ground and goes to pin 5. The LED has a resistor connected to ground, and the long leg goes to pin 4. Yeah? For the ultrasonic sensor, well, ground goes to ground and VCC goes to VCC, the power rails there, and the trigger goes to pin 7, whereas the echo goes to pin 2. So all this is all the same. I hope you didn't dismantle the circuit from past week because it's exactly the same. But today what we're going to do is that we're going to use this circuit and we're going to get it to control the car motors. Alright, so let's get to it.
Hello, and we are going to start coding now. Okay, here is if the car senses something in front of it. I want it to stop and I want it to do something. Alright, I don't want it to carry on, bang. No, that's bad. So I want it to stop and either turn left, turn right, reverse, whatever it is. Okay, so that's the whole idea. Okay, so as usual, make sure you have Arduino Uno selected, and we are going to robots to tell MBlock that we are going to form a Arduino program. Let's get this bigger a bit. I'm growing. Oh, my eyesight is bad. Okay, so Arduino program, and we want something to happen forever. Okay, as usual, we want to control it like a slave forever. So forever loop goes in. If you remember, if we are going to work with a ultrasonic sensor, we want to create a variable called ultrasonic distance. Go to data and blocks, make a variable, call it ultrasonic distance. Call it David's distance for all I care, you know, just a name. But choose an appropriate name, please. Okay, so ultrasonic distance. And what we want it to do is we want to set the ultrasonic distance to read certain feedback from the pins. Right? And in this case, the pin from the echo and trigger happens to come from pin 7 and pin 2. So let's get Arduino to take the ultrasonic distance from these two pins. Alright, so let's look for them. Here we are. So we are going to tell Arduino to take the trigger pin at pin 7 and the echo pin at pin 2. Okay? And this is what we want to do. We want to create a if-else statement. Okay? So we go to control. We choose a if-else statement. Okay? If something happens, then do something, or else do something else. Okay? So the else, if there's a blockage in front, do whatever we want it to do, or else we want it to go forward, right? Now, what I want to do is to create certain blocks now. It's going to make our lives a lot easier. Okay, so we are going to go to data and blocks, and we are going to make a block. Okay, we're going to make a block, and let's call this block forward. Type in forward. Right, and we are going to create a block, and this block is going to have instructions to tell the car to go forward, right? And so I need to go to robots, and what I'm going to do is that I'm going to create a digital pin 12 and 13, set digital pin here, duplicate this, bam, over here, digital pin 12 and digital pin 13, as both high. So this tells me that both motors, left and right motors, go forward. High means go forward. All right. And we want to set the brakes to low. So brakes are at digital pin 9 and 8. So let's duplicate this 2 and 9 left brake and 8 right brake. So we want to turn off the brake, so we put it at low and low. And now that we have, okay, go forward, turn off the brakes, we want to give it some speed. Yeah. So we're going to set the analog pin, which is here, PWM pin. We are going to have 2 motors with 2 speeds, and this fella will be pin 3 and this pin will be pin 11. Alright, so let's set the speed to maybe 150 and 150. So if both motors are going at the same speed forward, it should go forward evenly. That's the idea, of course. Alright, so like I was saying, if there's no blockage, okay, if there's a blockage, then do something, or else just go forward, right? So if you want it to, or else go forward, we drag this, or else go forward here. All right. Okay, so now we come to the what happens if there is a blockage, right? So if we need to compare, if let's say the distance, if the ultrasonic distance is less than, let's put it at 10 cm. Okay, so if there's a blockage less than 10 cm away, this is what we want it to do. We want it to stop. Okay, stop. Hold up. Wait a minute. Stop. Let's process this for a moment. Okay, and to do that, I tell you what. Let's go ahead and make all the rest of the blocks first, right? So let's make another block. Let's call this block STOP, stop. And to stop, I want both digital pins 9 and 8 to be high. Yes, because I want the brakes to be on. So 9 and 8, the 2 brake signals to be on, high. Turn on the brakes, stop the car. All right, and let's go ahead and make turn right. Okay, so I'm going to make another block saying turn right. So to turn right, this is my right. To turn right, I need to activate. To turn right, I need to activate my left motor, and to stop my right motor so that it'll turn right this way. Yeah. So let's copy this whole chunk here, bring it down here. My my right motor as 0, and my left motor carries on at this speed. Okay, so it's going to turn right. And let's do one for left. So let's make another block. Let's go left. Let's arrange the left block beside the right. Copy this whole chunk again. Copy it, and this time I want to switch the motor speed. This time it is like this. Yeah. And then let's go ahead and make one that says go back. Right, so make another block, and this time we say back. All right, and under back, duplicate. Under back, we want the motor to reverse, so pins 12 and 13 we go low to say go backwards. We still want the brakes to be off, and we can keep it at this speed, that's fine. Okay, so let's come back here to the main program. We've already created our blocks. These blocks will help us go forward or back. And now, if the ultrasonic sensor distance is less than 10, this is what we want to do. First of all, stop. Okay, first of all, stop. Hold it. Wait a minute. And maybe let's stop for half a second. Let's do that. Stop for 0.5 seconds. And what we are going to do is that we're going to come back here. What I want to do is I want to make another variable called robot choice. I want to make another variable called robot choice. So I want to set my robot choice I'm going to set a robot choice to a random number. So let's get it to pick randomly from 1 to 2 maybe. Yeah, 1 to 2. So if, now we come back to another control. If robot chooses, if the robot choice, sorry, let's go to operators. If the robot chooses, I know I'm just repeating myself. If the robot choice chooses choice 1, if the robot choice chooses 1, then turn right, maybe. So we can say turn right. And let's turn right for, how long should we turn right for? Maybe 0.5 second. Okay, but if let's go here, if the robot chooses choice number 2, if it chooses choice number 2, then maybe what we can do is we can reverse. Let's go backwards. It's up to you to choose, right? You can choose anything you want. Or let's turn left. 1 turn right, 2 turn left. Let's do that. And we turn left for maybe another half a second. 0.5 seconds. Okay, so here we have it. We can set a Arduino program that runs forever. And the first thing we do is that take a reading from pin 7 and pin 2, and let's call this the ultrasonic distance. We are going to measure the distance. If the ultrasonic distance is less than 10 cm, stop, hold up, wait a minute, stop for half a second, and tell the robot choice to pick a random number between 1 and 2. It'll decide randomly. If he chooses 1, turn right. If it chooses 2, turn left. But if there's no obstacle or else, just go forward. Okay, so we are going to upload this and we are going to see how our robot car works. Fingers crossed. Let's check it out.